Here in this Shanon entropy weight method, it is basically used for estimation of various weights, where the decision maker is required to estimate the weights for his attributes in solving the multi-criteria decision making problems. Here, Shannon developed some procedures for weight calculation by not going to consider with the decision variables. So here it is different from the earlier process which we have discussed as analytical hierarchy process. So entropy concept has been widely employed in social and physical sciences. Economics, spectral analysis and language modeling are few typical applications of entropy. So this was proposed by C.E. Shanon, a mathematical theory for communication in the year 1948. Entropy evaluates the expected information content from a certain message, where the decision maker should not decide based upon the criteria. Entropy concept in the information theory can be considered as criteria for the degree of uncertainty represented by discrete probability distribution. Entropy idea can be effectively employed in the process of decision making because it measures existing contrasts between sets of data and clarifies the average intrinsic information transferred to the decision maker. The procedures for objective weight through Shanon entropy method are: first thing is we need to normalize the arrays of the decision matrix to obtain the project outcomes Pij. So this is the formula for estimating the Pij. Next step is computation of entropy measure, that is Eij, entropy measure. This will be used by the formula this one, where here k is equal to 1 divided by ln into m, where m is the number of alternatives which we are having in our MCDM problem. And the third step is defining the objective weights based on the entropy concept. So this is the formula. From the earlier step we will try to calculate the weights. So let me go through the one solved paper taken from the SCI General, and by using an Excel software I will try to solve it and estimate the weights. So this is a decision matrix which has been solved by Manshadi for his material selection for a cryogenic tank, where the material should have, these are the various kinds of alternatives which we are having. For example, 7 alternatives we are having, and the outputs which he has measured as a toughness index, yield strength, elastic modulus, these three should be maximum the better, and the density, thermal expansion, thermal conductivity and specific heat should be as minimum as possible. Now these data I am collecting in an Excel sheet like this, okay, and based upon the procedures, the first procedure is normalizing it. So normalizing it, how I am going to take is, first thing is I need to take the current value. So the current value divided by the sum of the entire value, SUM, sum of this entire setup, okay, and then I will press an enter button. Now here is this sum is common through the entire matrix. So what I will do is I will double click it and I will insert a dollar symbol. So dollar symbol will try to fix the column throughout the entire part. So next one is I will try to drag it this one to the second case, and I will try to edit in and simply drag this one to, I will try to edit it and I will try to drag it to the second page, okay. Next similarly I will drag it to the third one, that is elastic modulus also. So in elastic modulus also I will try to drag it to the third position. This is the easiest way we can able to do it like this, okay. So simply by dragging the buttons we can able to drag it. Next for the fifth one we are going with the thermal expansion. Next for the sixth one again double click it, drag it to this extension. Next I will go double click it. Now we are at the thermal conductivity, drag it. The last one is the specific heat, so I will drag it here up to the specific heat. Now for this 6 cases, similarly I will drag it to the down size up to 7 numbers. Okay, up to, so I have taken 6, so I am removing this particular column. So 1 to 6, I have got 7, I have got it. Okay, so this is with the formula up to here. Next we will go with the second step. So in the second step, we are having the criterias to estimate the Pij. So I will just mark it this one as Pij. Okay, I will select this one, mark it up to borders. Okay, you can do this is Pij. Now my objective is to estimate the, see this formula is there. Okay, in this formula we are having computation of entropy measure project by using Eij. So first we will try to select Pij into log of Pij, then we will multiply that one with the k. So here k is equal to 1 divided by log of m. So we will estimate that one also. So what is k? K is equal to uh, first we need to know about m. No, m is equal to 7. So where k is equal to, k is equal to 1 divided by log of m, 1 divided by log of m. So that is equal to 1 divided by log of m. I'll get the k value. Okay, now this is the k value. Now based on the k value we have to estimate, we will go for calculating this one, Pij into log of Nij. Okay, so Pij is this one into log of Pij, we will get this value. Similarly we have to go up to here, and for all these values we have to do it summation also, no. So summation I have to do after multiplying Pij with Nij. So I will drag it vertically down up to 7. 1 2 3 4 5 6 7. Okay, so that if I try to open each value, this value is the log of this particular value. Okay, now I will try to estimate the sum value. So sum is equal to, here I will take sum of this is the formula. I will just estimate the sum, get the sum value. So this is the final sum value. Now the formula here is sum multiplied by minus k, sum multiplied by minus k. So I will take that is equal to minus of k is this one multiplied by this one, and k will be constant, no. So I will try to add dollar symbol here, so that row and column will be fixed. Okay, now I will drag this one up to here. Okay, and I will reduce it to 3 digits. This is called as Eij. So make a note, this one is Eij. Okay, that we are trying to fix it here. Okay, this is Eij. I will highlight this one, Eij. Now after estimating the Eij, we are having the next procedure as Wj is equal to 1 minus Eij divided by summation of 1 minus Eij. So for this one what we have to do is, we have to first think minus it, 1 minus Ei. Okay, so then I will drag it this one. So this entity will be 1 minus Eij. Okay, next one will be Wij. So before estimating the Wij, I need to know the sum of this one. So sum of this entire column will give me summation. This is the summation value. Okay, because in our formula we are having summation of Ei, 1 minus Eij, that's why. Okay, now I will try to divide each value, like 1 divided by summation. Okay, so for this one here, this will be constant throughout the problem. I will go for dollar symbol. I will make it as a dollar symbol, and I will try to drag it to the entire part. Okay, and this estimates me the these are the weights. If I try to estimate the, if I try to add all this one, I'll get 1 as my variable. So in that way also we can able to say that we can able to use these things in this particular manner. Okay, so this is the way, this is the procedure for estimating the weights by using a Shanon entropy